All right, people. I believe everybody is doing great, nice, and absolutely fine. So, let me know in the chats if I am perfectly audible and visible to each and every single student. So, my dear friends, in the today's session, we are going to talk about, we will be basically focusing on the units and dimensions. Okay. Since this is the demo class of Nimbus Pro, and if you have not joined this Nimbus batch, I would want you guys to join it as soon as possible. Okay. So, we are starting with the first chapter, that is units and dimensions, in the today's class. And I will be teaching you each and every single thing from the scratch. That is my guarantee. Okay. So, if you have not studied any of the things in this particular chapter before, let me just tell you, you are going to understand each and every single thing. As I told you, that is my guarantee. 100% for sure. Okay. So guys, this is basically the live session of, we say, units and dimensions for Nimbus Pro. And if you guys have not liked this session yet, I would want you guys to like this session as soon as possible, because liking the session is extremely mandatory. Liking the session is extremely mandatory. So everybody of you guys, and call up your friends. Okay, cool. If you're not like this session yet, I would want you guys to like this session. Hit the like button as soon as possible. Now, guys, listen to me very, very, very carefully. Let's not waste the time. Let's talk about this, we say, units and dimensions chapter. Units and dimensions chapter. The first thing we are going to talk about in this particular chapter is, that is what we call the physical quantity. That is what we call the physical quantity. See guys, when it comes to the physical quantity, we say a quantity that can be measured is called a physical quantity. A quantity that can be measured is called a physical quantity. Like we say length, okay, we say mass, we say velocity. Let me give you the example over here. My dear friends, let's suppose I have got a box over here, okay, and we say, sir, this box has a mass, okay. Now we need to calculate how much mass this box actually has. Let's suppose it is 20 kgs. So this mass is what we call the physical quantities. Physical quantity. This mass is a physical quantity. Why? Because it is measurable. We can measure the mass of this box, so that's why we call it the physical quantity. Let's suppose we have got a rod over here. And you took that tape. With the help of that tape measuring device, you said, sir, length of this tape is, we say, let's suppose length of this rod is, let's suppose, 2 meters. So this length is also a physical quantity. Why? Because we can measure this length over here. Okay. Now, if I ask you the question over here, this is a person A. Listen to me very carefully, my dear friends. I say, if this is a person A and this person A hates person B, we say, I'll write over here, person A hates, we say, person B. Person A hates person B. Now, if I ask you how much this person hates person B, you say, sir, person A hates person B. How much? We say, sir, 20 kg hate is over there. Is that correct? Saying 20 kg hate over here, is it correct? We say, sir, it is absolutely wrong. We cannot say, sir, this person A hates 20 meter this person B. So we cannot measure this hate. You can't say 20 kg hate, 20 meter hate. So we say this hate, it is immeasurable. It is immeasurable. It is immeasurable. So those quantities which we cannot measure, are called, we say, sir, non-physical quantities, are called, we say, non-physical quantities. And those physical quantities which can measure, like we have mass, we have length, we have temperature, we have velocity, all of these are physical quantities. And what is a non-physical quantity? We say, sir, hate, love, how much you love somebody else, okay, how much you have love for that particular person. Sir, you have 20 kg love for that particular person. Absolutely wrong. You cannot measure love. That is a non-physical quantity. That is immeasurable. That is immeasurable. So my dear friends, that's why it is mentioned over here. A physical quantity which is measured, which can be measured, a physical quantity which we can measure a quantity which we can measure is a physical quantity. Like we say length, we say mass, we say velocity, we say temperature, we say area, volume, density, etc. All of these are the measurable quantities. So that's why we call these physical quantities. Okay. Next, guys, next we have non-physical quantity. As I told you, when it comes to the non-physical quantity, we say a quantity that cannot be measured, is called a non-physical quantity. Like example we have got, we say, sir, sound. Sir, is sound a physical quantity or non-physical quantity? We say intensity of sound is a physical quantity. Intensity of light is a physical quantity. So sound and light itself are the non-physical quantities. Forget about it as of now. Don't think about this. We'll study these later on. We say goodness. How much goodness that person is having. Sir, 20 kg goodness. That is wrong. No, we cannot measure the goodness. So we say goodness is a non-physical quantity. We say love is a non-physical quantity. We say hatred is a non-physical quantity. All of these are, we say, non-physical quantities which we cannot measure, I hope this is crystal and clear till over here. Please let me know in the chats if everything is crystal and clear. Everyone means everyone. Okay, guys. Now, let's move on to the physical quantities which we have got. Guys, we divide the physical quantities in three quantities further. Okay, physical quantities are divided into, we say, fundamental quantities, we say supplementary quantities, and we say derived quantities. So physical quantities are further derived into, we say, fundamental quantities, we say supplementary quantities, and we say derived quantities. Cool? Yes. Now, what are these fundamental quantities? Guys, see. We said these are those physical quantities which are independent from each other, which does not depend upon each other. Let me give you the example. Over here, which will make you understand what I am trying to say. Guys, see. Let's suppose I say mass. We say this mass is an independent physical quantity. It does not depend upon anything. So mass does not depend upon anything. If you have to define the mass, you don't have to take somebody else's help to define the mass. No, because it does not basically depend upon anything. Now, let's suppose I say velocity. Guys, I say velocity. Or let's suppose I say speed. Since you guys are in the class 11th, let's talk about speed. Sir, when it comes to the speed, we say, sir, speed is distance upon time. You might have studied this formula previously. Speed is, we say, distance upon time. When you divide distance with time, then you get the value of speed. So we say speed is that fundamental quantity. I say speed depends. We say depends upon. We say speed depends upon. I say distance and time. Distance and time means if you have to derive the speed over here, if you have to, we say, explain the speed over here, you have to take the help of distance and time. So when you divide distance with time, then only you get speed. So we say speed depends upon distance and time. So it is not a fundamental quantity. We say not a fundamental quantity. It is not a fundamental quantity. We say it is not a fundamental quantity. But when it comes to, we say mass is a fundamental quantity. To define mass, you don't have to take the help of somebody else. So we say over here, length. Sir, length is also a fundamental quantity. Length is also a fundamental quantity. Like my dear friends, it's mentioned over here. We say physical quantities are divided into fundamental quantities, supplementary quantities and derived quantities. So fundamental quantities are those physical quantities which are independent of each other, which does not depend upon each other at all. Okay. And then we say supplementary quantities. Now, what are the examples of the fundamental quantities? Let me show you over here. These are the fundamental quantities. We have the total of 7 fundamental quantities. We say we have got mass, length, we have time, we have temperature, amount of substance, electric current, luminous intensity. These are the 7 fundamental physical quantities which does not depend upon each other. Now see guys, when it comes to length, it's SI unit. Sir, what is this SI unit? Please wait for few minutes. I'll make you understand what is SI unit. So basically what is mentioned over here is that we measure this length in kilogram in SI system. We say, sir, sorry, we measure the mass in, we say, sir, kilogram in SI system. We say 5 kg mass, 10 kg mass, 14 kilogram mass. Okay. Similarly, we measure this length in meters in SI system. We measure time in seconds. We measure temperature in Kelvin, amount of substance in mole, electric current in ampere. We say luminous intensity in candela. And you can see the symbol of kilogram is kg. Symbol of meter is M. Symbol of second is S. Kelvin is K. Mole is MOL. And ampere is A, candela is CD. So these are the 7 fundamental quantities which does not depend upon each other. Then we have got, my dear friends, supplementary quantities. As of now, I would recommend you guys to remember only what is the definition of supplementary quantities. We say these are the fundamental quantities. So these are the quantities. These are also fundamental, but they do not have dimensions. They only have unit. So these are those quantities which are dimensionless. They do not have the, sir, what is this dimension? Please wait for some time. We'll have to understand this in the upcoming lecture, please. So as of now, you just remember it as is, as it is. Next we have got, we say derived quantities. Next we have got derived quantities. We say these are the physical quantities which are derived from the fundamental quantities. Those quantities which are derived from the fundamental quantities, like guys, see. Let's suppose we have area over here. We have area. Sir, we say this area is length multiplied by breadth. So when you multiply length with breadth, then only you get area. So we say this area is it is a derived quantity. It is derived from length and breadth. It is derived from length and breadth. Similarly, sir, force is also derived quantity. It is derived from mass and acceleration. When you multiply mass with acceleration, you get force. Similarly, we say density. Density is mass divided by volume. When you divide mass with volume, you get density. So we say density is also a derived quantity. Density is also a derived quantity. Okay. Like we have velocity. Sir, is the velocity the derived quantity? Yes. Why? Because we say velocity is displacement upon time. Okay. And what is this displacement, guys? Understand very carefully. Displacement is length itself. If you measure the displacement, means you are measuring the length. Okay. And time is, we say, sir, this is second. Okay. Or we say time is time. So when you divide length with time, these are the fundamental quantities, length and time. So you basically get velocity. You basically get velocity. And acceleration is velocity upon time. So we say this is also a derived quantity, which is derived from velocity and time. Is this clear? Is this clear? Let me know in the chats, guys. Is this clear? Is this crystalline clear to each and every single student? Next we have got, my dear friends, the system of units. Like I'll tell you. What does the system of units actually mean? What does the system of units actually mean? Okay. Guys, see. Let's suppose we live in a country. The name of the country is X. The name of the country is X. We don't know which country. Let it be X country. Okay. And in this X country, there were different people. Okay. Now, they basically made a system over there. What kind of system, sir? They said, we will measure the length in. We will measure the length in meters. We will measure the length in meters. They said, we will not measure the length in foot. We can measure the length in foot also, centimeter also. But they said, we'll keep a common unit. We'll keep a common thing over here. That is what we call meters. We will measure the length in meters. We will measure the length in meters. Okay. Yes. Now, my dear friends, listen to me very carefully. And they said, we will measure the mass in. We say, sir, kgs. We will measure the mass in kgs. Okay. And they said, we will measure the time in, we say, sir, seconds. Time in seconds. Like 5 seconds, 10 seconds. Hey, how much time it took you from this state to that state, sir? 15,000 seconds, something like that. So they said, we'll measure the length in meters. We'll measure the mass in kgs. We'll measure the time in seconds. Okay. Now there is a country, another country. Its name is, we say, Y. Its name is Y. There is a country Y. And there are other people who live in this country. Different number of people live in this country. Now these people decided that we will measure this length in, we say, sir, centimeters. We will measure the length in centimeters. Okay. And they said, we'll measure the mass in grams. We'll measure the mass in grams. And they said, we will measure the time in seconds also. Seconds. Now, this is one country. They follow the another system of units. Like here, they are measuring the length in centimeter, mass in grams, time in seconds. Like this country is following the another unit. And this they call this system of units as, we say, sir, MKS system. MKS system. So in this MKS system, we measure the mass in kgs. We measure the length in meters. We measure the time in seconds. And they called this system of units as, we say, CGS system. CGS system. And in this CGS system, we say we measure the length in centimeter. We measure the mass in grams. We measure the time in seconds. So this is basically what we call the system of units. That's why we have got the different system of units out there. We say CGS system, centimeter, gram and second. That's what I explained already. FPS system, foot. Here we measure the length in foot. and we measure the mass in pound, 40 pounds, 60 pounds, 70 pounds, and we measure the time in, we say, sir, seconds, FPS. And MKS, we say MK is meter, kg, second. And then we have the SI system that we currently follow. And SI system is basically the modified version. It is the modified version of MKS system. So MKS system has been basically bit modified, and we called this then as SI system. So these are the different systems of units that people were following previously. Okay. Is this crystal and clear, guys? Let me know in the chats. Let me know in the chats. Let me know in the chats. I would want you guys to tell me in the chats out there. I would want you guys to tell me in the chats out there. Is everything crystal clear and sorted? Is everything crystal clear and sorted? Yes, great, great. Now guys see, listen to me very carefully over here. Now we have got different physical quantities over here. Like we have got velocity. Like we have got velocity. Like we have got velocity. Okay. We have got acceleration. We have got force. We have got momentum. We have to basically write their units in MKS system. We have to write their units in CGS system. This is our job. Now guys, see. When it comes to MKS system, that is meter, kg and second. Velocity is simply displacement upon time. Velocity is simply displacement upon time. Now, displacement is what? Displacement is length. Time is what? Time is second. So we measure the length over here in meters. So for velocity, instead of displacement, I write meter. And for time, I write over here second. So it will be meter per second. So the unit in MKS system for velocity is meter per second. For velocity is meter per second. Guys, see. I'll make you understand. I'll make you understand certain things over here. Let's suppose if we talk about measurement. Sir, what is a measurement? I'll make you understand what is a measurement. Everybody of you. See guys. Let's suppose I say I have got a rod over here. This is a rod. I am asking you to tell me the length of this rod. So basically you will have to do the measurement. You will have to do the measurement. You have to measure the length of this rod. Now you came and you measured the length of this rod. You said it is, sir, 2 meters. It is, sir, 2 meters. What is this 2? This 2 is what we call the magnitude. This is what we call the magnitude. How much is it? If I say instead of 2, it is 100 over here. So means magnitude of length is very large here. If I say instead of 2, it is 1000 over here. So magnitude of length is extremely large. Okay. Magnitude gives you the indication how bigger the quantity is. So we say it gives us the indication. It gives us the indication how big a quantity is. How big a quantity is. And what is this M? We say this M is what we call the unit. Unit means in what you are measuring. Like I am measuring the length over here in meters. I can measure the length in kilometers also. Like if I say distance is equal to 25 kilometers. What is this 25? We say, sir, it is magnitude. It is magnitude. And what is this kilometer? We say, sir, it is unit. It is unit. So kilometer is also unit. Unit means in what we are measuring. We are measuring over here in, we say, sir, meters. Like unit is over here. It is 1 meter actually. It is 1 meter actually. So now we say this is what we call the measurement. Measurement is always equal to, we say, magnitude multiplied by the unit. We say measurement is always equal to, we say, sir, n into u. So we say n is what we call the magnitude of that physical quantity, and we say u is what we call the unit. Now guys, we say when it comes to MKS system, in MKS system we say displacement is measured in meters and time is measured in seconds. That's why we call its unit is meter per second. And when it comes to the CGS system, in CGS system we measure length in centimeters and time in seconds. So instead of meter, I'll write over here centimeter per second. Okay, cool. Then we have velocity, acceleration. Acceleration is velocity upon time. What is the unit of velocity in MKS system? That is meter per second. So I'll write over here meter per second upon time. Sir, time will be also, we say, sir, second upon second. So it will be simply, that is meter per second square. It is simply meter per second square. And similarly, if I see over here, instead of meter, we write over here, sir, centimeter upon time. Over here will be centimeter per second square. Here it will be centimeter per second square. Then we have got the next one over here. Sir, force is equal to mass into acceleration. We measure mass over here and we say, sir, kgs. And acceleration, that is meter per second square. So kg meter per second square. And when it comes to this CGS system, here instead of kgs we write, sir, grams. Instead of meter we write centimeter upon, we say, sir, square. Gram centimeter upon square. Okay, gram centimeter per second square. And when it comes to the momentum, momentum is mass into velocity. This is the formula of momentum, mass into velocity. Guys, if you have not liked this session yet, I would want you guys to hit the like button as soon as possible. So momentum is mass into velocity. Mass we measure in, we say, sir, kgs, and velocity we write in, we say, meter per second. Velocity we measure in meter per second. So we say kg meter per second, kg meter per second. And here, instead of kg, it will be gram. Instead of meter, it will be centimeter upon, we say, sir, second. Gram centimeter per second. Next. Like, my dear friends, in this particular case, we have got, sir, pressure. What is pressure? We say pressure is force per unit area, force upon area. What is the unit of force in MKS system? That is kg meter per second square. So I say it is kg meter per second square. And then you have divided by area. What is the unit of area? It is meter square. It is meter square. This meter and square will get cancelled over here. So it will come out to be, that is kg upon meter second square. And when it comes to the CGS system, in CGS system, we represent this kg in, we say, sir, grams upon. We represent this meter in centimeter. And this, we say, sir, this is square. Okay. Yes. Next we have work is equal to force multiplied by displacement. When it comes to force, sir, for force, what is the formula for force? We say, sir, in MKS system, it is kg meter per second square. So I'll write over here, it will be, sir, kg meter per second square. Okay. Then we have multiplied by displacement, multiplied by m. Displacement we measure in meters. So I can write, this will be simply kg meter square upon, we say, sir, second square. And here we can write it, instead of kg, this will be gram. Instead of meter, you write centimeter square upon, we say, second. We say it will be second square only. And then we have density. We say, in case of MKS system, mass is, we say, sir, kg upon. Volume is, we say, sir, meter cube. Volume is, we say, length into breadth into height. So length we measure in meters, breadth we measure in meters, height we measure in meters. So that will be meter cube. It will be meter cube. And here in MKS system, we can write this is gram per centimeter cube. Gram per centimeter cube. Okay. Next, guys, let's suppose we are given a question something like this. Convert the momentum of a ball from MKS system to CGS system. Let's suppose we are given a ball over here. We are given a ball over here. We say mass of this ball is, let's suppose, 10 kgs. Mass of this ball is 10 kgs. And we say its velocity is 5 meter per second. We say its velocity is 5 meter per second. Now, guys, can you tell me what is the momentum of this ball? You say, sir, momentum of this ball is simply mass into velocity. So you say momentum is simply mass is how much over here? That is 10. Velocity is how much over here? That is 5. You write it something like this. We say this is 10 kg. Okay. And we say into 5 meter per second. So now momentum will come out to be, that is 10 into 5 is, we say, sir, 50. So it is 50 kg meter per second. This is the momentum that we got exactly over here. Now this momentum is given in MKS system because kg meter per second. Now we have to convert this momentum in, CGS system. Guys, see, we say to convert in CGS system, we say we can write it something like this. Guys, see, 50 I'll write as it is 50. Then kg, we have to convert kg into grams. Tell me, how many grams are there, we say, in 1 kg? You say, sir, 1000 grams is equal to 1 kg. So instead of 1 kg over here, can I put 1000 grams? Yes, I'll write 1000 grams. And then we have meter. So can I say there are 100 centimeters in 1 meter? There are 100 centimeters in 1 meter. Okay. Yes, sir. 100 centimeters in 1 meter. I'll write it over here. That is 100 centimeters is equal to 1 meter. So instead of this 1 meter, I'll write, we say 100 centimeters. And then we say divided by over here second will remain as it is. Now 2030, that is 5 and 6, total of 6 zeros. So we can write P is equal to 5 into 10 raised power 6. And then we say gram centimeter per second. This is the simple method to convert anything from MKS to CGS. Okay. Next. Let's suppose we are given a question something like this. Density is given as 6 kg per meter cube. You guys are supposed to convert this density into CGS system. We say to convert into, we say, CGS system. To convert this into CGS system, I can write this density as, guys, it is mentioned over here 6 kg. Now, in CGS system, we write kg in grams. So I write over here, this is 6, and how many grams are there in 1 kg? We say, sir, 1000 grams. This is 1000 grams divided by per meter cube. In 1 meter, how many centimeters are there? 100 centimeter. So I say, instead of this meter, I'll write 100 centimeter, and it has got cube over here. So I'll put cube over here. Okay. Now, guys, I can write it something like this. This is 6 into, I say this is 10 raised power 3 grams, because 10, we say 1 and 3 zeros. That's why 10 raised power 3. Upon. This is 10 raised power 2 centimeter, and we say whole cube. Now 10 raised power 2 whole cube. So 2 into 3 is 6. So I can write it something like this. This is 6 into 10 raised power 3 grams divided by, this is 3 into 2 is 6. So 10 raised power 6, we say, sir, centimeter. Okay. Now this will come out to be, if it goes in the numerator, 6 into 10 raised power minus 3 gram per centimeter cube. So it is cube here also. So gram per centimeter cube. Is this clear, guys? Is this clear? Is this clear? Okay. And there is a last question over here in this topic, that is what we call convert into MKS system. Density here is given in, we say, it is not, it is basically grams over here. It is grams over here. Density in this particular case is given 6 gram per centimeter cube. And you have to convert this in, we say, sir, in MKS system. And before this, my dear friends, I would want you guys to listen to me very carefully. See, since this lecture was for, we say, Nimbus Pro batch, okay, which is starting most probably from tomorrow onwards. This was the demo session. I hope you like this particular session. So we said this batch is, in this particular batch, the way I taught you over here, in the same manner I'll be teaching you in the batch. So you can see this is the Nimbus Pro batch, okay? And if you have not enrolled yet, it is starting today. So enroll as soon as possible. We say price is just 5,499. And with this price, you'll be getting the complete subscription of Unacademy. Plus subscription. You'll be getting the access to all the batches, not just the one batch. So I would want you guys to exactly, my dear friends, see, I would want you guys to basically enroll as soon as possible. So the link is in the description of this particular video. Click onto that link and join this. You'll be getting complete package over here. We say the test series. Okay. We say top-notch material. We say personal guidance by the educators, will be personally interacting with you. Okay. And lot of other features that you are going to get. And this is for the NEET 2026 batch. And I will be completing the physics in this entire batch. Wasim sir, HSP sir will be completing the chemistry, and Ambika ma'am will be completing the biology. Guys, if you have not basically enrolled in this particular batch, I would want you guys to enroll in this batch as soon as possible. Okay. So my dear friends, we say over here, take this plus subscription as soon as possible. So we say price has dropped. Now it is just for 5,499 rupees. So join it as soon as possible. Okay. So this particular batch, and see you guys in the batch itself. Till then, okay. Till then, we say solve this particular question, and we say comment down its answer. Okay. Comment down its answer. I don't want you guys to write the entire answer, but write over there done. Done, sir. So if you are done with this particular question, once I end the live stream, in the comment section, I want you guys to write done, sir. We have solved this particular question. So my dear friends, please do let me know in the comments later on, once I end the live stream, how was the session? Did you seriously like this session or not? Tell me in the comment section later on. So that's all for today. So thank you so much, people. See you guys very soon. Take care and bye-bye. Don't forget to basically like this particular session. Don't forget to comment on this particular session. And don't forget to join this Nimbus Pro batch that is starting very soon. That is starting from tomorrow itself. So take care and bye-bye. Thank you so much. That's all for today. So thank you so much. Take care and bye-bye.